So in this video, I'm here to explain to you why moving a metal bar through a magnetic field produces a voltage. Now we've learned a force law right here which states that if you move a charged object through a magnetic field, you're going to get a force. So pretty much what we have here is a bar, and that we'll call this our charged object. It has a bunch of electrons here, as you see. Now if you move the bar through, let's say, a magnetic field pointing this way, coming right at, or going into the page, and we move this thing with some velocity through the magnetic field, it's going to generate a force. And the force just happens to take place inside this bar. Now we can look at our right-hand rule to see where the force is going to be going. We have our velocity. We have our magnetic field right here, middle finger. And as you can see, velocity and magnetic field produces a force that's going to be going up. Now, since these are all electrons, this is our force, it's going to have the opposite effect. It's not going to push all these electrons up, it's going to push them down. Because the Q in this, maybe I should explain that better. Force isn't going to be up, it's going to be down, because our Q is negative. We have electrons, the Q is going to be negative. It's going to make our force vector down. So it's going to pretty much look like this after we move it through the magnetic field. All these electrons are forced down, and that makes positive charge over here. And what does that look like when we have kind of like a separation of charges? What does that generate right here? Generates a potential difference, or voltage, or emotional. It's going to generate a voltage or a motional EMF, electromotive force. And then once we have we could just figure out all kinds of things. We could find electric fields. We can find out how many volts. Later we're going to learn Faraday's law, which takes advantage of this whole principle, how moving a charge through magnetic fields produces voltage. Oh yeah, and one last thing is the migration of these two charges. It stops when the forces on them are equal. Okay, so they reach an equilibrium pretty much. The force down, and the attracting force between the positive and negative. When those forces equal each other, that's when the migration of the two charges stop.